Let's go ahead and take a look at case 3. This is the case where our degree of our numerator is greater than the degree of the denominator by 1. So we're going to be working with the function f of x equals x cubed minus 8 on top. And in our denominator, we've got x squared minus 5x plus 6. So let's go ahead and mark down the degree of our numerator. Our highest exponent here is a 3. And the degree of our denominator is a 2. Right, so this is going to meet the criteria for case 3. And we need to figure out, does this have a horizontal asymptote or an oblique asymptote? Right, and in this example, case 3 examples will have an oblique asymptote, always, and they are going to be in the form y equals mx plus b. Right, these are your slant asymptotes. They're going to be either lines that go uphill or lines that go downhill. Obviously, we'll draw them as dashed lines since they're the asymptotes. And the only way we're going to be able to find this line is to go ahead and use long division. So let's go ahead and set up our long division problem. I'm going to go ahead and account for any missing terms by placing zeros in there as the placeholders. Everything here is already in descending order. So we've got x cubed. I've got no x squared terms, so I'll go ahead and leave it as a 0x squared. Same thing with my x terms here. I'll leave a 0 in front of that. And then I've got my minus 8. And we're going to be dividing this by our denominator, which is x squared minus 5x plus 6. So let's go ahead and start our long division. Remember that we're going to be taking this first term, the x cubed, and we're going to be dividing it by x squared. And I'll make some notes down here to do this work. Alright, if we go ahead and divide these out, that's going to give us an x. So I'm going to put my x up on top, and I'm going to go ahead and leave it so that all my terms are kind of lined up. So I've got my x term up there, and our next step is to multiply. So we've got x times each of these pieces out in front. So x times x squared is going to give us x cubed. X times a negative 5x will give us a negative 5x squared, and x times 6 will give us a positive 6x. Our next step is to go ahead and subtract, and we're going to be subtracting each of these terms. So I'm going to go ahead and put those inside parentheses, and I'll put my subtraction sign out front. And be careful with your signs here. Right? We've got x cubed minus x cubed. Those are going to add up to 0 and disappear. We've got 0x squared minus a negative 5x squared. That's going to give us a positive 5x squared. And 0x minus 6x will give us a negative 6x. And then I'm going to go ahead and drop down my last term here, this negative 8. Now we can go ahead and start the process all over again. Right, this time we're looking at this 5x squared, and we're dividing it by this x squared that we see out in front. This is going to give us positive 5, so I'm going to go ahead and line that up above my constants here. And now we can go ahead and multiply the positive 5 times each of these pieces out front. So 5 times x squared will give us 5x squared. 5 times a negative 5x will give us a negative 25x. And 5 times 6 is 30. Right, and we'll go ahead and subtract each of those. The 5x squareds are going to subtract to give us 0. The got negative 6x minus a negative 25x. Right, your subtraction sign here and that negative in front of the 25, it's like making it a positive, right? Negative 6 plus 25. It's going to give us a positive 19x. And we've got negative 8 minus 30, which will be a minus 38. Right, and you'll keep going until you can't do any more rounds of division, and you'll notice that if I'm working with this 19x right here, this is not big enough for me to divide it by an x squared term piece, so I'm done with my long division. And students always ask, where does my answer come from? And that is up here on top. Right, we ended up with an x plus 5, and that actually becomes your equation for your oblique asymptote. So you've got the equation y equals x plus 5. You'll notice that I went ahead and graphed our function for us, and this oblique asymptote is graphed here in purple as that dotted line. The function f of x is graphed in blue, so you'll see that this one actually appears in two pieces on our graph.